Dear students, in this video we are going to discuss about the Frankel defect. In the previous video we have just discussed about the Scotty defect. Both of them are coming under the point defect. Okay, in this video, this Frankel defect, we can discuss one by one about the definition and characteristics with some illustration. Okay, let us see. According to the definition, the Frankel defect is the another form of a point defect and which is created when an atom or cation, especially cation, leaves its original position in the lattice to create a vacancy while occupying another interstitial position within the solid crystal. But in the Scotty defect, we have just seen about both positive as well as negative ions left the crystal lattice. But here only one cation must be leaving the crystal in order to form a Frankel defect. Let us see with some example. Here you can notice here the blue balls are meant for negative ions. These are negative ions, and the red balls are meant for positive ions. And here the size comparison between positive and negative ion must be too much high, because if you take positive ion as a smallest one, then the negative ion must be the biggest one. Okay, the negative ion must be the biggest one. So if this basic criteria is fulfilled, then we can expect Frankel defect. So what will happen when this Frankel defect? Here, if this small sized positive ion is leaving this crystal lattice, then a hole can be formed. As soon as this positive ion leaving that crystal lattice, due to its small size, it may be going and occupying somewhere else in the same crystal itself. Okay, the place where this positive ion is occupying is known as interstitial site. Okay, interstitial site. What is known as interstitial site? Interstitial site is nothing but the place which is normally established by when the normal arrangement of positive and negative ions taking place. Okay, so therefore here in this case there is the possibility of a normal positive normal vacant site. So that vacant site can be occupied by the small sized positive ion. So what are the characteristics of Frankel defect? This defect occurs only when cations are too smaller. We have to note it down. When compared with the anions, there are also no changes in chemical properties. This we know that. There is also no significant impact of Frankel defect on the density of the crystal, because in the given volume, of the crystal lattice, the missing of positive ions is not leading to the permanent removal of the same positive ion from the crystal itself. Okay, it may be occupying the very nearest interstitial site. So with a given volume, with a given fixed or constant volume, the mass will be remaining. Therefore, no density change was observed, as in the case of Scotty defect. Because in the Scotty defect, both cations and anions are simultaneously removing the place, the crystal, permanently. But here, this cation is occupying in the very just nearby position. Then, in such cases, substances also maintain their electrical neutrality. What do you mean by electrical neutrality? Electrical neutrality is nothing but if you have one positive, then negative must be accompanied with that positive charge, and vice versa. If you take 100 cations, then it requires 100 negative charges. So this is known as electrical neutrality. Since this positive ion is not permanently leaving the entire crystal system, therefore the electrical neutrality is constant. Let us see finally some examples. Here silver bromide, zinc sulfide are the best examples for this Frankel defect. So therefore, my dear students, thanks for watching the videos. Let us meet in the next video. Thank you.